Hi, ladies and gentlemen. We are looking at notes 1.3, which are on domain and range. So if you take a look at this reminder right here, you already should have this in your notes, what domain and range are, but let's just do a quick reminder of what domain and range mean. So remember, the domain of a function is the set of all inputs for which the function will can give an output. So it's all your inputs or all your basically x values, okay? And the range of a function is the set of all outputs, or basically all your y values for which there's an input that results in them, okay? So basically the domain is just what are the inputs that are going to work in your function, and then the range is just basically what are all the outputs that are going to work in your function, okay? So in question number 1, it says for each relation, state the domain and range and whether the relation is a function. So in part A right here, if you look, we have 1, 2, 3, 4, 5, 6, 7 different coordinates. This is actually called a discrete relation. And the reason why this is called a discrete relation is because it is just a point and then another point and another point. It's not connected. So the opposite of a discrete relation would be like a continuous relation. So because my dots are not connected to each other, then my domain is going to be simply the x values that correspond in these dots that I have right here, okay? So the first x value that we have right here, the first point that we have is -3, -2, but the x value, just simply the x value that I have is -3. So when I want to list out my domain, the first value I have is -3. The next value I have right here corresponds to -2 on my x-axis. So -2 is also in my domain, okay? This right here is a coordinate. If I were to write this out as a coordinate, it's -1, 0, but the input is just the x values, so the domain part of it is just going to have a -1 in it, okay? The next value that I have is at 0. When x is 0, I have the coordinate 0, 1, right? So the next part of my domain is 0. Then the next part would be 1, and the next part would be 2, and then finally it would be 3. So these are all the values that are in my domain, just -3 and every integer on until I get to +3. Now, I can list out my values if it's listable. So here we have a finite number of values. We've got only 7 values in my domain, so I'm allowed to list it out. But if it's a continuous function, it would mean if I were to like connect these dots, which don't do on your notes, I'm just showing you. If I were to connect these dots right here, then my domain would be every single value from -3 until +3, because it could be any little decimal value between all of my dots that I have here, because I would have infinite points from -3 to +3. So that's one way to write my domain. The other way to write my domain, instead of listing it out, is I could say that my domain, and this notation is going to be a little bit different than what you guys are used to, is just simply my x values are going to be an element of the integers. So I want you guys to write yourselves a note that capital Z, like a double bar line Z like this right here, just simply means integers. So remember, integers are just positive and negative whole numbers, okay? So right here, my domain would be all the integers between -3 and +3. So what does this mean right here? This is saying that my domain consists of integers, and this is saying that it's going to be between -3 and +3. So that's what this inequality right here means, okay? So that's another way that I can write my domain. Now we need to find the range of this function, and to find the range, I'm going to look at my y values, because my range is my set of outputs, okay? So if you remember, we said that this coordinate was -3, -2. So this right here, this value right here is going to be my output. So I can say that my range is going to start at -2, okay? And then the next coordinate is -2, -1. So the next value is -1. Here, the output, the y value is at 0. Here, the y value is at 1. here the y value is at 2, and I would just keep going. So this is at 3, and then this one is at 4. So again, because it's discrete, it's just a finite number of points, I can list out my range. Or I could say that my range is y is an element of the integers, and such that, that's what this line right here means, by the way. I forgot to mention that for the other one. So I'm going to put a line right here such that y is between -2 and 4. Okay, and that's how I find my range for this question. The last thing I'm going to do is look and see, is this a function or not? It asks me to figure out if the relation is a function. So does each input only have one output? Absolutely. Also, if I were to do the vertical line test through every single point right here, it only intersects my relation once, so therefore I can say that it is a function. So I'm going to say right here, yes, it's a function. Because it passes the vertical line test. Okay, and I'm done with question A. All right, so let's take a look at question B right here. So B, the relation that we have here, I want to know, is this going to be discrete or continuous? Well, in fact, it's actually neither, because in order for it to be discrete, it needs to have a bunch of disconnected points. But here it is connected with one another, and here it is connected with one another as well. However, it's not continuous either, because there's a break in our graph right here, so we can't say that it's a continuous function either. Now, just one thing I want you to realize is with this open circle right here, it means that it is not defined here. So there is no actual value when x is -5. When x is -4.9999999 and it gets really close to -5, there is a defined value. But because there's an open circle here, it doesn't work here. Just like when we graphed things out on the number line, and if we had like x is greater than 3, we would never have shaded in the hole in 3. Okay, so now that we've discussed that, the fact that it's neither discrete nor continuous, I still want to figure out what my domain is going to be. So my domain, remember, is going to be all of my x values. So my domain, because it's every single little value in between, it's not going to be just integers. It's going to be all values. So x is going to be an element of all the real numbers, okay? And x starts at -5 right here, but doesn't include the -5. So this is my starting point for my domain on my x-axis, and it's going to keep going all the way until I get to this value right here, okay? Now, one thing I want you to realize is even though it's an open circle here, we would normally say it's not defined at 5 if there's an open circle there, but there's a closed circle up here, so it is defined at 5. So that means right here that we can say that 5 is still part of my domain, okay? So what we're going to do is we're going to say x is an element of the real numbers such that x is between -5 and we'll say this is probably about 11. So -5 is less than x is less than or equal to 11. Now, why do I have a less than sign here? Because over here it's not defined at -5. It's an open circle. Why do I have a less than or equal to sign here? Because it does actually reach 11. So 11 is still part of my domain. Now looking at my range is going to be my y value. So if I look right here, the lowest y value that I have here on the y-axis is about right here, and the highest y value is about right here. Okay, so I know that my range is going to be within this area right here. So therefore, I can say my range would be from 2 to 6. But here's the issue with saying that my range is from 2 to 6. It's only defined, my outputs here are only going to give me 2 as my outputs. And the only outputs that I get here are 6, right? So that means that I only have 2 specific values in my domain, or in my range. So this time I'm just going to say that my range is plain and simply this value right here, which is about 2. okay? And then this value right here, which I'm going to approximate to be about 6, and that's my range, okay? There's nothing else in between. I'm not going to say it's an element of the integers because it's literally just 2 values. That's it. They happen to be integers, but I don't have to specify that, okay? All right, so the last thing I need to do is determine, is this a function or not? Well, when I draw in any vertical line, it always passes the vertical line test. But the question is, does it pass the vertical line test when x is equal to 5? And it does because it's an open circle here and a closed circle here. So when x is 5, the only coordinate I have is 5, 6. 5, 2 is not a coordinate right here because it is an open circle. So I can say, yes, it's a function. And for the same reason, because it passes the vertical line test. Okay? All right, so now let's look at C. In question C, this time we can definitely say that this is a continuous function. How do I know it's a continuous function? Because if I were to draw it out, draw on top of my function, I can draw it out without having to lift my pen or my pencil once. So now when I look at the domain of my function right here, first of all, it's a parabola, right? So to find the domain, I'm going to figure out, well, what inputs are working? What x values will result in corresponding y values? So if you notice right here, it appears that my x values are from -2 until about 4. But these arrows right here tell us that this parabola is going to keep going on in both directions. So no matter what my input is here, like even all the way down here to -1 billion, I'll have a corresponding y value. It's just going to be super low down here, right? So the domain is going to be every single x value from -infinity to +infinity. So what we say is we just plain and simply say that x is an element of the reals, because no matter what input I put in here, I'll always get an output. Another thing to pay attention to is, don't forget, like the standard form of a parabola, of a quadratic function, is ax squared plus bx plus c. Any x value I plug in here will always yield a y value. So every input I use will always have a corresponding y value, okay? Now, here's where things get a little bit trickier. For the range, I have a bunch of y values that work, and we know that this is going to go on forever on both sides, so we know that it's going to start at -infinity, or it's going to go down to -infinity, we should say. So that's our lower limit, but our upper part of our range is it's just going to go up to this point, and then at our turning point, it turns back around and goes back down to -infinity. So for my range this time, I'm going to say that it is y is still any real number, but y has to be less than or equal to 3. And that's where, if you remember vertex form of a parabola, so f of x is equal to a times x minus h squared plus k, where h comma k is your vertex, that will help you identify the range of any quadratic function immediately just from the vertex, and whether the graph opens up or down. And we'll talk about that more in detail when we get to that, okay? And then the last thing that we need to do for this question is to determine whether it's a function. And yes, it is a function because it passes the vertical line test. No matter where I draw my vertical line, any vertical line I draw will only intersect with the graph once. So we'll say, yes, it's a function, and we'll use the same reasoning. Yes, it's a function because it passes the vertical line test. Okay? For question D, I want to figure out the domain and the range as well. So to find the domain, I'm going to look at my x values again. And I know that the farthest left my circle will go is -5, and the farthest right my circle will go will be +5. So that way I can say that my domain will be all values, all x values from -5 to +5. But it's every single little x value. So every single decimal that could be between -5 and +5 is included in my domain. So my domain is x is an element of all the real values, all the real numbers, such that x is between -5 and +5, including those values. Okay? I want you to pause the video and try to find the range, and then compare your answers with me to see if you are on the right track. Okay, so you should get the range is y is an element of the reals such that y is between -5 and +5. Okay, and it's really important that you remember to put the y here and the x here because it does not make sense to put x for range. Okay, lastly, is this a function? Does it pass the vertical line test? Absolutely not, because this intersects my vertical line twice, or my vertical line intersects the graph twice. Even though it works here, it doesn't work in at least one place, multiple places, but in at least one place, it automatically is not a function. So we're going to say no. It's not a function because it doesn't pass the vertical line test. Let's take a look at question number 2. Find the domain and range of each function. So part A, the first function that's given to us is f of x equals 5x minus 3. So one thing I want you guys to realize is that f of x equals 5x minus 3 is in the format f of x equals mx plus b. Therefore, we can say that this is a linear function, okay? Now, for any linear function, if I were to graph it out, all of my linear functions always have a y-intercept and a slope, except for vertical lines. So if every function has a y-intercept and slope, it always starts somewhere and then it goes up and over or down and over, except for vertical and horizontal functions this time. So if I take a look at any line that I were to draw that's not vertical or horizontal, I can see that any x value I plug in will always have a corresponding y value and only one corresponding y value. Therefore, I can say that the domain of this function is going to be all real values, no matter what kind of a line it is, unless it's a vertical line. Okay, if it's a vertical line, then the domain is just going to be whatever value of x the vertical line is drawn on. Okay, so that's the domain. Now, to find the range, right here, whenever I plug in any value right here, I'll always get some type of y value, and my range, since these lines go on forever, and specifically on this line, I would start it at -3, and then I would go up 5 and over 1, and my graph would continue forever in both directions. So I can say that my range of this graph is y is an element of the reals as well, because it will go from -infinity right here to +infinity. And same thing with my x values, they go from -infinity to +infinity. And this is true of every single slanted line. Okay? All right, so now question B right here. To do question B, I have to recognize what type of a function that I have here. So this time for this function, I know it's in the format, the same format we just talked about on the top right here, a times x minus h squared, sorry about that, plus k. So we know that this is a parabola or a quadratic function in vertex form. Okay, so just by looking at this right here, I know what my vertex is going to be. I know that the vertex is plain and simply, remember this is going to be a +4 because it's x minus h. So since this is x minus 4, the 4 has to be, or sorry, the h has to be a +4 for this to stay minus, right? And then the k value is 5. So I know my vertex is 4, 5. And if you remember from the 2D class last year, this is going to open up, or sorry, this is going to open down because the a value is negative. So because it opens down and it has a vertex at 4, 5, I'm going to go to 4 on my x-axis, 5 on my y-axis, and it's going to look like this. I know that my graph is going to look something like that. Now, obviously, that's a rough sketch. There's a lot more factors to the graph for me to actually be able to graph it out. So now, that's enough information, though, to find the domain and the range. I know that the domain, for any parabola, the domain is always going to be all real numbers. How do I know that? Any value I plug in here, I'll always get a y value, a corresponding y value, no matter what the value is going to be. Remember, this goes on forever on the left side, and this goes on forever on the right side, okay? So the range is going to be different than the domain. So for the domain, x could be any value because it goes on forever in both directions horizontally right here. But the range is all your y values, so how far down it goes and how far up it goes. So it's very similar to question C that we did up here. Now with a line goes on forever in both directions, but a parabola reaches its maximum y value and then it goes back down. So because it's continuous, y is still going to be an element of all the reals, but specifically y values that have to be less than or equal to this value right here, which is the coordinate, the y value of our coordinate right here, which is 5, which is the k. And that's how you can easily figure out what your range is right here. Okay? Lastly, question C, what is the domain going to be? At this point in time, you don't know exactly what this graph is going to look like, and that's totally fine. We're going to learn a little bit more about this type of graph later on this unit. But the thing that I do want you guys to realize is that this is just a square root. So when I'm taking the square root of any value, the number under the radical has to be positive. Now a radical is the square root, okay? So the number underneath the square root has to be positive. If it is not positive, then you can't take the square root of a value. So like for example, if I asked you to take the square root of -49, using real numbers, it's impossible. You can't take the square root of -49 because no number multiplied by itself will ever give you a negative. Two positives give you a positive, two negatives give you a positive. The only way you can get a negative is if the signs are opposites, then it's not the same number, therefore you can't take the square root, okay? So what this means is that what's under the square root sign right here has to be positive. So that means, what conclusion can I make from that? That means that 7 minus x has to be positive, or in other words, it has to be greater than or equal to 0. Sorry, I should be more specific. It has to either be positive or it could also be 0 because I am allowed to take the square root of 0. So I'm allowed to have it be equal to 0. So moving the x over, x has to be 7 has to be greater than or equal to x, or in other words, x has to be less than or equal to 7. So therefore, I can say the domain here is x is an element of the reals such that x is less than or equal to 7. Okay? Now, the question is, what's the range? Well, before we talk about what the range is, one thing I just want you guys to be aware of is if I were to give you an equation, for example, that said x squared equals 25. Okay, when I solve this, I need to square root both sides, right? So I end up getting x equals 5. But 5 is not the only answer that x could be. 5 times 5 gives me 25, but -5 times -5 also gives me 25. So x could be plus or minus 5 right here, okay? However, in this function right here, with no sign in front right here, it's assumed that it's a positive square root, which means that all your answers are either going to be positive or 0. So that means that your range has to be all real numbers that are greater than or equal to 0. The last thing I want to do is show you what this graph looks like on Desmos really quickly so we can just verify the domain and range, and then we will be done, okay? So I'm going to graph out k of x equals the square root of 7 minus x in Desmos. So k of x is equal to the square root of 7 minus x, and I end up getting the graph that looks like this right here. So if you notice, this goes on forever on the left side, so it's going to keep going on to negative infinity. So my domain is going to be from negative infinity all the way until I get to 7 right here, and then my graph stops. So that's why my domain here is what we ended up getting right here. X is less than or equal to 7, okay? For my range is going to be from 0 all the way up to positive infinity because it starts at 0. That's my lowest point, but it's just going to keep increasing and increasing and increasing, okay? So that's it for the video. Question 3 we're going to do together as a class because this video is long enough already, and we can kind of discuss what we want to do for question number 3. All right, have a good day.